Okay, so in this video I'm going to use, we're going to be using Wireshark to do our first packet analysis. So I already have Wireshark installed on my Windows 7 virtual machine. So I'm going to go ahead and boot up my Windows 7 virtual machine. So before we get into this, what does Wireshark do? So remember that all information that travels across the internet, either from our computer to a server or from a server to our computer, it travels in these packets. And Wireshark allows us to look at the actual packets that are being sent. So we can do packet analysis and we can see the actual bits being sent from one computer to another. So when we're doing this, before we jump into Wireshark, I actually want us to install Firefox. And the reason that I want us to install Firefox is the first thing that we're going to look at is we're going to look at the connection between our computer and a very basic web page. And we don't want a bunch of other things going on in the background. If we used Internet Explorer for this, Internet Explorer is going to have all sorts of additional connections open, and it's going to kind of make our packet analysis kind of messy, and it's going to be harder for you to like actually follow the stream of the the connections. Anyway, so we're going to double click on Windows Tools right here. We're going to double click on the Firefox installer. Notice the size of this, it's really tiny, so it's just going to download it and install it from the internet. So you don't have to take this and drag it onto your desktop. You can just double click on that and hit run and hit yes. Hopefully you guys have a folder on your desktop that says Windows Tools or something like that. If you don't have that, look at the shared folder lab that we did, I believe, last week. So now this is going to go ahead and install Firefox for us, which is good. And we're actually going to, once this installs, we're going to make Firefox our default. So now, why not use Google Chrome? Well, Firefox is actually lighter than Google Chrome at this point, a little bit quicker, and it's a little bit better for privacy, so it doesn't add on additional packets. It doesn't send a lot of additional things. Actually, we're going to turn that off. So this, I'm just going to click right up in here. Hopefully when you guys click in there, if I click in here, I'm going to go to change options, and I don't want to provide search suggestions right there. So I can uncheck that, provide search suggestions, and then I can close out of this, close out, close out, close out of this. Launch Firefox again. This time when I launch Firefox, it's going to ask, do I want to make it the default browser? Yes, go ahead and use Firefox as my default browser. So when I close out of it, reopen it, this time, hopefully I don't get any weird errors or anything. Okay, so the web page that we want to go to is the last web page on the internet, which is www.1112.net slash last page.html, and this is the last page on the internet. I'm actually going to switch to full screen mode for this. Hopefully you guys watched my video about the different video modes so you know how to switch between the different ones. But the reason we want to use this web page in particular is it's a very simple web page. So if I right click on here and I view the source, there's only like 13 lines of HTML code. So this is a very basic, web page, which is good. That's exactly what I want. So I got this, the last page of the internet, loaded up onto my Firefox, and now I'm going to go ahead and open up Wireshark. Okay, so with Wireshark, we might notice right here, this is where our connections would be. So all of the different connections that you have to, these are network interface cards, or we only really have one right here, don't worry about this, USB PCAP. We just have this local area connection because we're on a virtual machine, but if you were on like a laptop or something like that, you might see multiple. We could have both wireless and wired network adapters. On a desktop computer, on the desktop computers that we have at school, they're just wired connections, but a lot of times you're going to be looking at wireless captures in here. So if I just click on this local area connection right there and I start Firefox, or I start Wireshark right there, We're going to be getting all kinds of packets like already, and we're not even doing anything. Especially like if we open up like crazy, I open up Internet Explorer, close out of this. If I open up Internet Explorer, just take a look at this. We got all kinds of random packets in here. So it's a little bit, that is a little bit confusing. So we're going to close out of this, quit without saving. I'm going to reopen up Wireshark, and I'm going to use a filter called HTTP. So, traffic on the internet goes through different ports, and different ports allow for different things. So, like, web page traffic goes through port 80, which is HTTP, or HTTPS, which is a different port. But then you have like Skype traffic, and that goes through a different port. And then you have FTP, or File Transfer Protocol traffic, and that goes through a different port. And Pop Mail, that goes through a different port. And then your Xbox or PlayStation, that information goes through different ports. Ports are ways for the internet to kind of organize information, and so everything's not going through the same channel. We kind of break the information by type into these different channels. So we're gonna be looking at a web page right here, and web pages are on port 80. The port 80 is also called HTTP, or Hypertext Transfer Protocol. Anyway, we're going to go ahead, and now that we have HTTP in there, we're going to go ahead and start this. And we might get a few little M searches here. We might get a few things. Okay. Let's not worry too much about that. What I'm going to kind of look for here is I'm going to refresh this page. And when I refresh this page, notice I kind of get this right there. Okay. And I got some kind of information there. And now that I've done that, I'm going to go ahead and hit stop. So this is exactly what I'm looking for right here. Kind of this stuff up here, I'm not exactly sure what this is. I can actually look it up in a minute. But let's take a look at this traffic down here. So as soon as I hit the refresh button on my page, I got all of this green area popped up, and then this green area popped up down here. So this is really what I'm going to be looking at. The first thing that I want to look at is the source and the destination. So the source is a number 10.0.2.15. That's my IP address. So an IP address is just like your home address, but it's a number for the internet. So all information has to know where it's being sent to and where it's being received. I'm going to open up start cmd, open up the command prompt, and type in IP config on here, and notice my IP address is 10.0.2.15. The source is 10.0.2.15. So basically, whenever I see on here 10.0.2.15, either in the destination or in the source, that is my computer. So when I see 10.0.2.15, in either of these cases, that means my computer. The other address that I see is this 172.245.130.175. That is actually this web page right there. So if I type in here 172.245.130.175, the same web page loads. Okay, so we use this thing called DNS, or domain name service, to basically translate like google.com into the IP address, because everything on the internet is IP addresses, our computer, all servers and everything. But these numbers like 172.245.130.175, that's pretty difficult to remember. So rather than us remembering that, we remember like this 1112.net, which isn't that much easier to remember. Or like we would remember google.com or yahoo.com or espn.com. We would remember a name, and then we use these DNS servers to translate that name to the actual IP address. So this 172.245.130.175, this is the server's IP address. Okay. Now I noticed right up here we got a couple of different web pages up here. So I kind of want to go to these and just check them out. I didn't plan for this. but I'm going to go to 184.26.143.114. Just kind of see where that goes. Oh, whoops, let me try that again. 184.26.143.114. So it's giving me like this invalid URL. So it looks like this isn't an actual web page, but it's definitely an address of a computer that was trying to communicate with my computer. So it was 72.21.91.29. So this is a CRL. I do not know. Anyway, these were computers that were connecting to my virtual machine for some reason. But the actual connection that we want to look at is right down here. So we notice we still have like this information right here. We have all this information kind of up here. All I want to do is focus on the connection between my computer and this web page, the last page of the internet. So in order to do that, I come down here and I look for this. It's an SYN. So this is a synchronization packet, okay? And it's from my computer to this 172.245.130.175. I'm going to click on this, and I'm going to go to follow TCP/IP stream, okay? So what that is going to do is that brings up this information right here, which is kind of useful information. We can see like the host web page. Okay, we can kind of see that we're using Firefox, and we can kind of see some other information right here. This could be useful later on. What's really nice though is notice our stream kind of got a whole lot less cluttered. So this is just looking now at the connection that I had between my computer and the web page. Okay, and there are three different parts of this that I want to talk about. The first part is called the three-way handshake. So that is the first three packets. Whoops. If you accidentally click on that, click on time because we want to talk about this in time. So the first three packets is our three-way handshake. So the first packet that's sent is from my computer to the server. And this is a synchronization packet. Basically, this is me trying to connect to the server, say, hey server, do you exist? Can I connect to you? And I want to when we're starting a conversation, I want to start at this particular point. Okay, so if we take a look in here at our, sorry, let me flip this open and flip this open right here. So I opened up our TCP I clicked on the packet one time right here, and we can take a look. So by the way, all of the information that's in this one packet, I can kind of see right here. So this is all of the information that's sent in this one packet. It's not very much. This is the hexadecimal code for it, and then if there was any like values, we could see it over here. So I'm gonna flip open this TCP information right here. We can kind of see we have some IP address information right here that's also sent. This is our header. Everything's being sent over IPv4 or Internet Protocol version 4. Here's our source address, my computer. Here's the destination address. I think we talked about before in the header of every packet contains the destination address and the source address. In the TCP information, this is what I really want to look at. And then in here, I want to look at, well, I'm going to look at a couple things. First thing that I'm going to look at is the stream index is number 5. So you might go, well, the 5. Remember how before I had like some other random connections in my stream? This is just Wireshark's way of kind of organizing different streams. So this was the 5th connection that it saw in the one stream between my computer and this particular server. So, and it kind of allows us to organize just the information between our computer and the server. So that's what the stream index is. The flags right here that I want to take a look at. You should have watched the other video about the different flags, whether it's like the urgent flag or the acknowledgement flag or the push. Notice how all of these have zeros, which means off, 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 or not. And the SYN flag is set right here. So the SYN flag is on right there. So basically what this says is, hey, I want to start a conversation with you, and I'm going to start my conversation at this number. Um, Now it would say for me the sequence number says like 0 right there, but this is a relative sequence number. So this basically, as a human being, we like to start numbers at number 0, and then every conversation after that, so we can go 1. So you'll notice the sequence number here is 0, meaning this is the first one. The next part of this conversation will be sequence number 1, and then the part after that will be sequence number 2. So it's really easy for humans to start at 0 and then think 1, 2, 3, 4, 5. Computers actually don't do that. Our sequence number is like this number right here, this 08. So if I like click on the sequence number, we can kind of see the sequence number. Oh, there it is right there. So it's this 10.71.E5.62. So it's kind of a random spot, but it's basically just saying to the server, hey, I want to start a conversation, and this is going to be my starting point for the conversation. So every part of the conversation after this, we're just going to increase. So something else that's kind of important in here is this window size. So the window size is basically how much information or how big of a packet my computer can receive at a time. So this is saying that my computer can receive 8,192 bytes per packet. And actually that number can be bigger because I have this Windows scale thing right here. I don't want to get into this later. I can actually send more information. But that's what this is kind of telling me right here in this window size. This is telling me how big of a packet I can be able to accept at any given point. So 8,192 bytes. Okay, so that was our first packet, me sending it to the destination. Now notice right here, now the server is replying back to us, and it's replying back in both a SYN and an acknowledgement packet. So if I go here and I open up the TCP, notice the flags in this one. We're going to have two flags that are open. We have one, an acknowledgement packet, and one is a SYN packet. So this acknowledgement packet right here, this is basically saying, hey, I acknowledge that you want to start a conversation with me, and I acknowledge all of the information that you sent in this packet. So I acknowledge the window size and where you want to start the conversation, like the synchronization number and all that. By the way, I also have some of that information too. And so I'm going to send you a SYN packet. So notice this thing sends me its window size. So it can actually handle information a little bit bigger. It can handle bytes as much as 65,535. So the server can handle much bigger packets than my computer can. But it's just telling my computer, hey, I can handle packets up to this size. And it's also saying like, okay, this is the acknowledgement number 1. So this is, remember, you started at number 0 right there, and then this is number 1 right here. So this is the next packet. Again, these are relative numbers. So relative numbers, this isn't actually the number. The actual number can be seen in the bits right down here. This one's 10.71.E5.63. If you kind of remember right here, this one was, I think, which one was this? 10.71.E5.62. So we can see the actual number right here, 10.71.E5.62, and then the following one is 10.71.e5.63. So it's increasing in numbers. This right down here, that this is a relatively difficult number for a human to remember. So basically, Wireshark makes this a little bit easier, and it just goes, you don't have to remember that whole thing right there. We're just going to go with 1. So this is basically, we started with 0, and then this is number 1. So this is the next packet after that. Okay, and then right here, I acknowledge. Okay, so if we look again right here, we have our sequence number. Basically, I'm acknowledging. So this is the next packet in line, and I'm acknowledging that, remember, because this sent the acknowledgement packet of all the information in this synchronization packet, but then this computer also sent its own synchronization packet that included like the window size right down here, which is giant and stuff, and basically I'm acknowledging that information. So the again, this is called the three-way handshake. So we start with my computer going to the server saying, hey, can I talk to you? And by the way, when starting this dialogue, I can only talk in this big of a byte, so I can't have really long sentences. My sentences or my packets can only be 8,192 bits or bytes. And yeah, the server responds back and says, I acknowledge that. Yes, we can definitely start a dialogue. And by the way, I have my own synchronization information. My window size is a little bit bigger, but we can start a dialogue. These don't have to be the same. And I go, okay, I acknowledge that your synchronization stuff, and I think we're ready to talk. So this is our three-way handshake that's going on right there. This is just establishing the connection. So the first 3 packets in here are just establishing the connection. Now, the next bits of packets that I want to talk about are the next 3 packets right here. So it's a GET request, an acknowledgement request, and then actually we're downloading the HTML, and then an acknowledgement request. So I want to talk about the next 4 actually. So the next page right here, this is a GET request. So notice this one, now we're actually, when I was clicking on these packets before, we're transferring some, this is our header information, our IPv4 information, and we have some TCP information right there, but we don't have anything else right there. We have we're not really transferring information. As soon as I click on this GET request, now we have that header information right here, the IPv4 address and the TCP information, but I also have some information right here, this HTTP Hypertext Transfer Protocol. Okay, so this is right here, this is the first information, and it's not from the server to my computer. This is actually from my computer to the server, and this is me asking, this is a request for a particular web page. This is a GET request for this last page.html. So basically I'm saying, hey, on your server, you have this page called lastpage.html. It's an HTML page, and I'd like you to give it to me, and I'd like you to use the Hypertext Transfer Protocol, or HTTP, to be able to send it to me. Okay, so this is me just asking, hey, can I get this page? The next thing right here is just an acknowledgement packet, okay? So notice there's nothing sent yet. This is just header information. This is just the server saying to my computer, okay, I got your request for the web page. The next thing that it does is the server sends me the actual web page to my computer. So we have the server sending to my computer. Now, if I look in here, we have this HTTP information, and in here I also have some line-based text. So let's take a look at this line-based text. This information right here, this is the actual HTML code. So if I right-click on here and I go to View Page Source, notice these 13 lines of code. This is what's being sent right here. This information right there, like now turn your computer off and go outside, now turn your computer off and go outside. So the actual web page is being sent in this one packet right here from the server to my computer. The next packet right here is from my computer to the server, and this is an acknowledgement packet. This is me telling the server, okay, I got your web page. You sent the web page to me, and I was able to download it. So that's what's going on. So again, in these 4 packets right here, I go, hey, you got this web page called lastpage.html. Can I get that? And the server goes, okay, I acknowledge that you want that lastpage.html, and I'm going to go ahead and send that to you. And then it sends it to me in this packet right here. This is the actual server sending me the packet, and then and then I respond back to the server going basically, thank you, I got the web page. Now we have 4, 1, 2, 3, 4 final packets at the at the end of this connection, and this is called a 4-way handshake. So we noticed we had our 3-way handshake up at the beginning. The 3-way handshake establishes a connection between our computer and another computer or server. The 4-way handshake closes that connection. And sometimes there are small cases in which it's not always for a 4-way handshake. Like sometimes one computer will close the connection in the server, but for the most part, it's a 4-way connection. So the first thing that's done is from the server to my computer, the server is going, okay, I acknowledge that you got the web page. I have nothing more to give you, so I want to go ahead and close this connection between my computer, the server, and your computer. That's what the server is saying to me. And then my computer goes back to the server and say, okay, I acknowledge that you want to close the connection. Okay, so that's fine. And then I go, I want to close the connection too. Can you acknowledge that? So the connection between the server sending me information has now been closed, but I can still send the server information, and I don't necessarily want to keep sending the server information too. So I'm basically saying, hey, I also want to close this connection, and the server responds back to me in this packet by saying, yep, cool, we can close the connection. So we have our 4-way handshake going on right down here, where basically the server's telling me, okay, I finished sending everything, let's close this connection. I go, okay, the connection between you and me is closed. Now I want to close the connection between me and you. And the server goes, okay, that's closed too. We're good. So that's what's happening right here. So we have our 3-way handshake at the beginning, opening the connection. Then the data is sent in the next 4 packets. And then the final 4 packets down here are the 4-way handshake closing the connection. Okay, and you can kind of see like right down here, like this fin. I forgot to open up, but we can open up the flag, and you can see we have the acknowledgement flag is on and the finish flag is also set. So anyway, hopefully that kind of makes sense to you as how information is sent over the internet, how connections are established, information is sent, and connections are closed. And we can look at all of every single one of the packets that's sent. We can kind of look at that information in here. Okay, let me know if you have any questions. Let me break out of this full screen. I hit Control C on my computer twice, and remember it's right control, and that's it. Okay.